What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovy, and in this series we're building your game. In the last episode, we recently added this new enemy called the crab. However, as you can see, the crab doesn't really do much right now. So what we're going to do is we're going to give it the ability to shoot bullets. But before we do that, I'm going to teach you guys how to use the AnimatedSprite library and how to use libraries in general when you're working with Lua projects for Playdate. Small caveat, if you're new and you're just watching for the AnimatedSprite tutorial, then let me show you guys how you can get on board to this project. So you should see the link for the GitHub of this Playdate tutorial down in the description below. And in there, so first of all, you can hit this green code button when you're on GitHub and copy the HTTPS link. And then you're gonna go into a terminal and you're gonna type in git clone, and then you're gonna paste the link to the project. Now this command will just copy the project onto your computer, and then from there, you'll see that there's actually branches for each of the episode. So I would do git checkout ep-16, or this one, 21 or 22 or something, /start. And then at that point, you're going to be at the start of this episode, exactly where you need to be. Looking forward to having you guys in the project or on board. If you're just here to learn, that's cool too. For everybody else who's following, let's get right into it. What are libraries? Libraries are basically code that somebody else wrote that you can bring into your project and not have to rebuild from scratch. And because I showed you guys already the basics of animation, I thought it would be more interesting for us to use this library instead of recoding everything ourselves, which would take a lot of time. And honestly, even if I was doing this for my project, I would just use this library. So right now we're looking at the white brim / animated sprite library. So what you're gonna do is you're gonna actually open up the link again in the description. You can find it in the resources, and that'll bring you to this page. And here we have a small example of how to use the library, which you don't have to worry about because I'll teach you guys today. And then you've got the code base. Now, the funny thing about most Lua libraries is that you only need one file to make it work. Now, you can go all crazy and install with Toybox and all that, but honestly, for 90% of cases, it's not necessary. Let me show you guys how to do it the quick way. You have this file called AnimatedSprite.lua. That's gonna be your file. So we're gonna go ahead and click on that file. And because my internet speed is like if I'm living in the Sahara, we're gonna have to give it 1 minute. All right, so now that we have our file, you can actually just press up here in the top right corner of the little file example and just copy the raw file. So this will copy all the contents of that file, which we can go and then bring into our project. So we're gonna create a new folder inside of the source, and we're gonna call it libs. Not lubis, not loves, libs. And then inside that libs folder, we're gonna create a new one called animated, I'm going to use the normal casing that I do, AnimatedSprite.lua. And so now that we have our AnimatedSprite.lua, we're going to actually paste the contents of that file right there. And congratulations, you've imported the library into your project. Let's just follow our normal standard for how we import things. So we're going to create a libs.lua file in the source folder, and we're going to do import, in quotes, libs/AnimatedSprite, matching the case. Then I go back to my main file. I also import libs, in quotes, underneath assets. And there we go. Now we have the animated sprite inside the project. So now let's take a quick look at the library and how it works. So you can see that first of all, AnimatedSprite extends the playdate.graphics.sprite. So that's good to know. That means that anything that we expect the Playdate sprite to do, the AnimatedSprite can also do. Then we've got the init function, which basically takes an image table. So not just an image, but an image table this time. A list of states, an animate. But honestly, for the states, we're going to do it separately. Afterwards, we're just going to set them one by one, just because it's a bit cleaner. And in the states, we're going to be able to define like from what frame in the image table to what frame in the image table. And then we have a whole list of parameters that we're going to take a look at as well in a second. So let's just start using it. So we're going to use it specifically on the enemy class, because we've got two different enemies and they're gonna have different image tables with different animations. By the way, just small thing. I actually created two different files for this episode. There's going to be the crab bullet, which you can see is a tiny, tiny little bullet right here, right there, which macOS is rendering with some weird anti-aliasing. And then we're going to have the crab table 3232, and you can see that he kind of does this Kame, Hame, Ha animation right there for when he shoots the bullet. The important thing is to take those two files, which again, you can find them in the description below, and drag them into our assets. And now there will be a conflict with the crab table 3227 because our assets is only importing the file name crab. So we do have to delete the old one with 3227, keep the 3232 one there. And the crab bullet, we can add that to the assets as well. So let's open assets.lua. After bullet, we're going to add bullet crab equals, in quotes, assets slash bullet dash crab. If you're joining and you just joined with the episode start, you're actually going to have both of the image files. You just need to add them in the assets. Let's go back to our enemy class and let's implement the animated sprite. So instead of playdate.graphics.sprite at the top, we're actually going to type in AnimatedSprite right there. So I've typed it in the documentation, but I'm also going to put it inside the class enemy.extends AnimatedSprite. Now our type checker is angry. He doesn't know what an AnimatedSprite is. And that's because Mr. Whitebrim hasn't added the type checking to the class. So I'm going to go ahead and add that into the file in the project, which is a nice thing that you can do. So I'm going to add 3 lines above the class, and I'm going to do at class AnimatedSprite playdate.graphics.sprite. And then I'm going to add a line underneath that, which is going to be AnimatedSprite with the same like capitalization as the class itself equals empty table. So open, close, squiggly brackets. Yeah. And so that's going to enable the type checking everywhere in our project. And as you can see, the type checker stopped complaining. If we run the code now, we should run into an error because we're giving an image instead of an image table. So we're going to just rename this image inside the enemy:init parameter to image table. And then enemy.super.init, we're going to rename it to image table as well. Great. Good job, guys. And then in the crab, so then we have to change this image to an image table for both the crab and the jellyfish, which are 2 different types of enemies. So we've got image table crab inside crab:init, and we're going to replace we're actually just going to remove the square brackets and the 1 after image table crab, because now we're just going to be using the image table.
Easy!
And funnily enough, it's the same thing in jellyfish. I'm going to go to the jellyfish.lua, jellyfish::init, and I'm going to remove the square brackets and the 1 from the image table jellyfish passed into the init parameter right there. All right, we can run it and see what happens. Let's press A, refresh. So the jellyfish is moving as expected, and I'm not seeing any crabs, which is a little bit worrying. We don't have any errors, so that's a bit of a weird one. Let's finish up the task because there's actually more stuff we need to do. So the jellyfish has a custom animation loop that we can remove now that we've added our animated sprite. And instead of that, we're going to add the initial state for the jellyfish. So the jellyfish only has one state, which is, so we're going to set the default state right there. So we're going to do jellyfish to super.init, image table jellyfish. Next line, we're going to do self : add state, open brackets, in quotes, idle, and then we're going to give it the frame. So the start frame is 1 and frame is 2. In the parameters, we can basically customize many different parts of the parameters, which we'll look at later. The only one we're going to do now is open, close, squiggly brackets. So it's going to create a table, and we're going to pass in one parameter, which is called tick step, and we're going to pass in like 16. So tick step basically means how many ticks need to pass before I switch to the next frame. And so we're really slowing down the animation, or else our jellyfish will be having seizures constantly. So instead, we're just gonna slow that animation down. And then there's gonna be a last parameter, which is animate. So we can pass in true, so that the add state actually enables that initial animation as it's being passed in. We're going to do a similar thing with the crab, except the crab is actually going to have two different states. So again, if you refer back to the image, you know that there's going to be like the moving state, which is going to be like chest bumping or rave dancing or whatever you want that to be. And then there's going to be the shooting Kamehameha animation. So we're going to go into crab.lua and we're going to add two different states underneath inside the init function. So we're going to do self::add state, and then we're going to, so instead of using quotes, because we're going to be reusing those states, we're actually going to create a separate enum above. We're going to go above the class definition. We're going to do local, and we're going to say animation underscore states. So again, we're talking about a constant enum, so we're going to use all caps with underscores, animation states, const equals open close brackets, and we're going to have two of them. We're going to have moving, and we're going to do equals 1, and then we're going to have a second one, which is shooting, equals 2. So those are two animation states. So we're going to do so back to the init function, we're going to do self::add state, and we're going to do animation states dot moving, comma, and again here it's going to be 1, 2, and then params. I'm going to do tick step equals 16, so open close table, tick step equals 16, and then instead of doing true at the end there, I'm actually going to go to the end of that function, so close the brackets, and I'm going to do dot, and you can see that it's adjusting it as default, and open close brackets on there. So that's going to set that as the default animation. We're going to add the second one, which is going to be self::add state, open brackets, animation states dot shooting, comma, and so this is going to start from frame 3 until frame 5. 3, 5, and we're going to do tick step, and I'm going to make this one even slower. I'm going to do 32 as the tick step, so that he's really like charging it up slowly and then shooting, and we don't need to set that as default. But because we're not saying the parameter true for starting the animation, we're going to trigger the animation manually, which is going to be play animation, open close brackets. All right, now that we've set all those things, let's run the game. Ready? Oh, sorry, we forgot to remove a line from the jellyfish update, which is the one that animates using the loop. We're going to remove that one right there. So the last line of jellyfish update, we can go ahead and scrap that. Let's run again. And you can see that nothing is animating. Good job, everybody. Woohoo! And that is because, and I know this because I spent 30 minutes on it yesterday, enemy.lua inside the update function needs to call the super.update. So with the PlayDate SDK, it's not critical that you call it. But with AnimatedSprite, there's no animation if you don't call the AnimatedSprite functionality. So inside enemy.lua, in the enemy::update function, we're going to add the first line to that function. We're going to do enemy.super.update, open brackets, self. And that's going to call the AnimatedSprite function for update. Let's try again, and we can see that both of our guys are animating. Our little squiggly jellyfish are moving, and the crabs are doing their little chest bump party stuff as well. But now we need to get the crab to actually shoot at us. So how are we going to do that? So let's go into crab.lua. And let's see, we have this distance to player is greater than 100 piece of code, where it's like, if it's more than 100, then we move towards the player. If it's less than 100, we don't move anymore. However, we need to shoot the player at that point. So instead of the end after that if statement, we're going to say else, and we're going to add self::change state. So this is going to be one of the AnimatedSprite functions. And then we're going to pass in animation states dot shooting. And then so now it's going to be shooting at you basically. So it is complaining that integer should not be a string, and I also have that complaint here. So we're going to change our enum from a number-based enum to a string one. So instead of 1, I'm just going to type open quotes and type in moving, and then I'm going to open quotes for shooting and typing shooting as well. So now that we're using strings instead of numbers, the type checker will stop complaining. I think AnimatedSprite works with both, but to be extra clean, let's just use strings instead. Now the problem is we also need to change the state to moving if we're in the moving part of it as well. So we're just going to add that change state moving there as well. Let's run the game and see whether, oh, there we go. You can see him doing his little Kamehameha thing as soon as he gets close to me. 1, 2, 3. That's looking pretty cool. So our last thing that we need to do is shoot the bullet using this crab. So how are we going to do that? Well, let me show you guys really quickly. Let me step you through the parameters of the animated sprite library. So again, here you have a list of parameters, but there's no documentation about them. So we're going to scroll down until we get to this part, which is the add state functionality. And then here you actually have all the parameters described. So we can kind of skip over. So like there's the default one, there's the name. Then if you want to pass in like non-sequential frames, so for example, you want an animation to be frame 1, frame 5, frame 8, you can actually pass in the frames manually as the frames parameter instead of just the start and end frame that we were doing with just 1,3, for example. And then you've got collision frames and SFX frames. So these are new. I believe they're kind of like triggers for when you have these specific callbacks, which we're going to see in a second. We don't have to worry about those for now. Then you've got next animation. So the nice thing about this one is that you can actually pass in an animation state to switch to after this animation ends. So for example, let's say that you have a landing animation. Your player lands on the floor. You want it to transition back to the idle one after the end of that. So you would pass in next animation equals animation states dot idle or whatever that might be. You've got loop. We're setting it every update, but if you want it to automatically loop, you would set the loop to true. You've got reverse if you want to play it backwards. Tick step, which is the one that we saw, so that's how slow do you want it to be. And then you've got frame step, which is how many images do you skip in the image table. So for example, if you wanted to go twice as fast, you would skip every second frame. Then you've got yo-yo, which is kind of like, do you do 1, 2, 3, 1, 2, 3, or do you do 1, 2, 3, 2, 1, 2, 3, 2, 1, like that. You've got flip. So if you want to just flip the entire sprite around, this is how you would do it. You would set the flip parameter to true on all of your animation states. Then you've got X scale, Y scale, which scales the sprite. And then you get to the callbacks, which is the one that we want to take a look at now. So you've got frame collision and frame SFX, which are the two ones that we just saw above. And then you've got the 4 frame and state change callbacks. So here you've got, for example, a frame changed event. So that means that every time the frame of the animation changes, you're going to call this callback if it's passed in. Same thing with the state change. So every time the state is changed, then you're going to have a callback that you can call. Then there's going to be a loop finished event. So if you get to the end of the animation and restart, then it's going to have a specific callback, and then the animation end. It's similar to loop, but it's when the state ends after this animation. So what we want to do is that we want to call the shoot bullet function when the crab is on the last state of the animation. So we're going to go ahead and add it to our parameters for the shooting state, and we're going to do it on the frame callback. So I'm gonna do, what's the name again? On frame changed event. So on frame changed event equals, and then I'll pass in a function that belongs to the crab. So I'll do crab dot on shoot frame changed. And so the nice thing there is that the callbacks will actually pass in the animated sprite that's calling that callback. So you could actually pass in the crab dot and some function that belongs to the crab, and it will pass in the self that's needed for us to add a colon function. So if we go after crab dot init and we add function crab colon on shoot frame changed, then it's actually going to pass in the self, so we can use that colon without any problems. And then the last thing we're going to do is we're going to check the number of the frame to make sure that it's the correct frame that we want. So we're going to do if, and then this is part of the secret functionality of AnimatedSprite, even if you can still use it. We're going to do if self dot, and then you've got underscore current frame. So the underscore is meant to be private, so don't set that anywhere, but you can read it if you're sneaky. Self dot current frame equals, and so we need to check whether the frame is equal to the one that we want, which is frame 5, which is the last frame in the animation. And then here we can add a comment, shoot the bullet, and then we're going to do end. So for now we're just going to put a print statement saying shoot. Oh, sorry, because we're doing Kamehameha, we're going to do ha. All right. Nice. We can refresh the game and see whether this works. All right, let's get closer to the thing, and oh, he shot, and we go to the console and we can see it says ha. Poof. Time travel French over here, just to save your guys' little butts. I just realized that we broke the collision regs for all of these enemy sprites because AnimatedSprite doesn't know how to handle collision regs by itself. The real reason for that is because inside enemy.lua, inside the init, we're setting the collide rect before we actually set the first state up. So even if it has the image table, it's not setting the size of the sprite based on the image table. It actually waits for the first state to be set up, which in my opinion is kind of stupid because image tables are always the same size. So let's make a quick fix for that by replacing the self : get size with image table in brackets 1 get size. And so now you're actually getting the image table size from the first frame of the image table. And let's refresh. And now that if you have your little pink squares in the game, you should see that everybody has their collision rect as expected. All right, guys, I'm gonna cut it off here because this is as much as we have time for today, but I'll be back in the next episode with the actually shooting the bullet as well as any other funky crab behavior that you guys might want to put in. I will see you guys in the next one. Bye-bye.